Hello guys, welcome to i-tutor Academy. In today's session, we will start with the Unit 11 MMPC005 and subsection 4. It's testing of population mean. We shall now discuss how tests concerning population mean can be developed and used. Under different conditions, the test procedures have to be developed differently. We start by discussing the case when the population variance is known and the distribution of sample mean Z is known to have or can be approximated by a normal distribution. When population variance is known, we again refers to the purchase manager's decision problem first introduced in section 11.1. Already we discussed, and 11.2 also we discussed. You just go through last video and revise it. The purchase manager has to decide whether to buy casting from a new supplier who has claimed this that his casting have higher hardness than those supplied by existing suppliers. The purchase manager knows that the mean hardness of casting supplied by existing suppliers is 20 and also that the standard deviation of hardness is 2.5. To test the claim of the new supplier, he picks up a sample of 100 casting from the new supplier and finds that the sample mean is 20.5. The purchase manager believes that the standard deviation of hardness of casting from the new supplier would not be very different from that of the existing suppliers. If the purchase manager decides to use significant level of 5%, what should be concluded? We have seen earlier that unless and until the sample evidence is strongly to the contrary, the purchase manager would not like to switch from the existing supplier. The null and the alternative hypothesis are therefore set up as follows. Okay, so this is the hypothesis. So here is one chart also, the critical region. This is the area is shaded. Okay, so this is a equation based valuation, and one tailed and two tailed test also there. In the previous section we looked at a test where the critical region was found to lie under one tail, the right tail of the distribution of the test statistics, and such a test are called one tailed test, in contrast with the two tailed test where the critical region lies under both the tails of the distribution of the test statistics. We shall now look at such a situation. And let us assume that our purchase manager want to test whether the mean hardness of castings supplied by one of the existing suppliers has changed from 20. If it has changed from 20, then he would like to take some corrective action. On the other hand, he would not like to initiate the corrective action unless and until he is reasonably sure that the mean hardness has really changed. Okay. So you just go through your material, IGNOU study material, and here is equation based explanation also there, because this is all based on, this is a hypothesis based on all examples, or you just try to relate your real life and all things, then it will more easy. Okay, acceptance region for the two-tailed test. Here is the chapter based one chart also there. When population variance is unknown, we have so far seen assuming that the population variance was known, and so we could easily calculate the standard error of the mean. And however, in many cases that population variance is not known and we still want to draw conclusion about the population mean. Sample size is large. When the population standard deviation is not known, we have to estimate it from the sample, and as we have discussed in the previous unit, we use the sample standard deviation S to estimate the population standard deviation. Okay, and the sample size is small. When the sample size is small and the population standard deviation is unknown, the standard error of mean cannot be found directly. However, as we have seen in the previous unit, if the population's distribution is normal, the sample standard deviations can be used to calculate the value of a related random variable. So these are the unknown and unknown population sample. The two-tailed test of mean for small sample size. So here is a chart and equation also here. So you just go through your IGNOU study material MMPC005 Unit 11 subsection 4. Okay, and testing of population proportion. We shall now discuss how tests concerning population proportion can be conducted. At this stage, we would request you to review the previous unit where we discussed the determination of confidence interval for the population proportion. In particular, In particular, recollect that the sampling distribution of the proportion is actually a binomial distribution which can be approximated by a normal distribution with the same mean and the same variance if n is sufficiently large so that the both np and n close 1 minus p are at least as large as 5. Okay, and here is also two-tailed test of proportion in figure is here. So you just go through it your material, and activity is based on that. You just try to do this activity based on the section, and it will more clear for you. In case any doubt, you can contact us. Okay, and testing for difference between mean. Many a time the decision maker is interested in knowing whether two related populations are different from each other in respect of any parameter of the population. Example, the marketing manager may be interested in knowing whether the mean sales from a retail shop is affected by a display at the point of purchase. A personnel manager may like to know whether the job performance of a category of employee is affected by a particular training program. In this case, the decision maker is not interested in concluding anything about the parameter value in either of the population. And independent samples. We first discuss the case where we want to arrive at some conclusion about the difference between two population means, and we draw one sample from each of the populations and independent of the other. So we have two dependent samples and we want to test the difference between the two population means based on the evidence produced by the two samples. Sampling distribution of the difference between sample mean, that is, let us assume that the mean and variance of the first population are here, and it's based on equation. You just go through your material and test when sample size are large. Okay, so that's also here. You just go through it and it will more clear, because equation we can't explain like that. You just do it your own way. Okay, testing for difference between mean and large independent samples, that is the figure based approach is here. And test when sample size are small. When the sample size n1 and n2 are small, we cannot substitute s1 for sigma 1 and s2 is sigma 2 and proceed and sigma 1, and this is all based on the calculations. Okay, so you just do it your own way. It will be more clear. And next is, here is also the figure is here, one chart is here, and dependent sample. We have so far discussed the case when the two sample picked up from the population were independent, but we can also design our test in such a way that the sample are dependent. For example, if you want to know whether a training program helps in improving the job performance of a category of employee, we can evaluate the job performance of a sample of employee before they have undergone the training program. We can evaluate the performance of the employee again after they have undergone the training program. In general, using dependent samples is better than using independent samples, because the effect of all other major factor is eliminated and the difference can be attributed only to the treatment that we are studying. Such a design may not always be possible, but whenever we can design a test based on dependent sample, we are relatively more confident that we have isolated the effect of the treatment and that the two samples are identical, but for this difference is in treatment. Okay, and here is one table, weekly sales in a sample 11 retail shop. Okay, based on that there is a cutoff value and figure or based explanation are there. And next one is testing for difference between proportions. A marketing manager want to know if there is any difference in the proportion of consumer who like the taste of his product. He find that 40 out of sample of 85 consumers respond that they like the taste of his product. Similarly, 35 out of the second sample, 65 consumers respond that they like the taste of the product when they are administered a product of the next competing brand. Based on these observation, what should the marketing manager conclude at a 5% significant level? Okay, so here is based on the equation and explanation, and the test for difference of population proportions are there. And activity F is here, activity based on the section. So you activity G also here, and you just go through this and try to do the activity. It will more helpful for your term and examination. Maybe questions, maybe you can expect one or two questions, and the summary is here in this chapter. In this unit we have seen how tests concerning statistical hypothesis can be designed and used. A statistical hypothesis is a statement about a population parameter or about a population distribution. As these tests are conducted on the basis of evidence thrown up by a sample, errors cannot be totally eliminated. All tests are designed to answer the question, and it is the sample evidence strong enough to reject the null hypothesis. The null and the alternative hypothesis are set up such that one of them and only one of them is always true. In the absence of a strong evidence to the contrary, the decision maker would be willing to accept the null hypothesis. Of the two errors that are possible in any testing of hypothesis, type 1 error wise, the error is wrongly rejecting the null hypothesis is considered to be more serious than the other one, and so is subject to explicit control. Okay. And self-assessment exercise is based on the lengthy question. So try to do this because it's all based on the hypothesis and proportion based. So try to do this, and in between any doubts you can contact us on our number or you can comment it on our comment box. And for more IGNOU MBA videos, you just do like, share and subscribe our channel. Thank you for your support. Thank you so much.
i-tutor Academy presents IGNOU MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.